Okay, for those of you who are here in the meantime, sorry for the delay again. It's just that the previous class ended up later again. I'm going to be back shortly and we will begin and continue with electrostatics. I just need to go to the bathroom quickly and I'll be back shortly. So if you guys haven't already, maybe you guys, because I'm going to solve this question next, maybe just attempt this while you're waiting. Yeah, give this a go. Okay, cool. Hey, assalamu alaikum and good morning, people. Welcome back to grade 11 physics. In today's lesson, we'll be continuing with electrostatics. Okay, well, I really do apologize for the delay. I will definitely always be trying to keep this class on time, even though we are notoriously always starting late. But yeah, nevertheless, let's continue. We will end a bit late, probably by around 12. Okay, so let's have a look at this question that I asked you guys to try. Okay, did anyone, firstly, did anyone try it? Secondly, did anyone give an answer? If you have an answer, please tell me, then we can, even if you want to just put it in the Q&A or something. Did anyone get an answer? It's quite a difficult question, so it's expected if you struggled with it. Okay, actually, we need to finish this one first before we finish this. I remembered. Okay, but let's just recap this question either way, right? So, just 1 second. Let me just sort this out. Okay, so yes, we have, okay, let's read the scenario first. It says that the two charges above are made to touch and are then separated. Okay, so which two charges? The charges of 8 microcoulombs and negative 20 microcoulombs. They are made to touch and are then separated. Then we annotated in the diagram that the electrons are moving from negative 20 to the 8. So they're moving from Q2 to Q1. Why are they moving from Q2 to Q1? Because electrons always move from more negative to less negative. Okay, so that's why they're going to move from negative 20 to 8. Okay, so that's important for us to understand. So then let's look at the calculations we did, okay? They said that the two charges above are made to touch and are then separated. Calculate the new charge after contact. That's a formula which we title Q nu. If you want to calculate the value of Q nu, we say Q1 plus Q2 over 2, right? And that's exactly what we did. We said 8 plus negative 20 over 2, and we got a Q nu of negative 6 microcoulombs, right? Remember, we also said you don't really have to use SI units in these questions. You just need to make sure that you use the same units. So for example, if your one charge is in microcoulombs, make sure that your other charge is also in microcoulombs and that your answer is also in microcoulombs. If one is in nano, make sure that they're all in nano. If one is in coulombs, make sure they're all in coulombs and so on, right? So you just need to, for this first formula, you don't have to use SI units. Remember, what is the SI unit? The SI unit is coulombs. You can use coulombs. It's just that you don't have to, okay? So yes. Then the next question was calculate the charge transferred. Can you refresh the Zoom? It's not working. Is the Zoom working fine for the people who are on Zoom? Is Zoom working fine for you guys? They are telling me that the Zoom is working fine. So maybe just restart your Zoom or try to rejoin. Like close Zoom, open it again, and try to rejoin. Click the link again. Okay, because there are people in Zoom and it says and it's working. Make sure you click the right link. Make sure you're not like on the maths link or something. Okay, so let's continue. So calculate the charge transferred. Okay, so this is the formula. This is a question where we use the formula for delta Q, because delta Q is change in charge, which is charge transfer. Again, same thing, right? SI units. You don't have to use them. You can use them, but you don't have to use them. You just need to make sure that the units are that you use the same units for all charges. That's the most important thing. And you have delta Q is equal to Q new minus Q old. That's the formula for charge transfer. That's the formula for delta Q. So Q new minus Q old. Now we have one Q new, which is -6 microcoulombs. Then we have two Q olds, okay? And if you choose the less negative charge, you're going to expect a negative delta Q. If you choose the more negative charge, you're going to expect a positive delta Q. Okay, so just keep that in mind. That's very important. Remember, we discussed it here, right? Now, the -20 guy, he is donating because he's the more negative one. He's donating. So what happens when you donate electrons? You become more positively charged. So that's why his change in charge is a positive change in charge. Okay, and then this 8 microcoulomb guy, he's the less negative one. So he's the one that has to receive. When you receive electrons, you become more negatively charged. That's why his delta Q is negative. Okay, important to understand. Okay, so let's move on to the last one that says how many electrons are transferred. So when it comes to electrons transferred, we know one formula actually, and that formula is Q is equal to N times QE. Q is equal to N times QE. Okay, just let me know if you come right on Zoom and if it works. Okay, Q is equal to N times QE, where we said Q is the charge, right? Remember we discussed this formula. Q is the charge. Okay, this is just the rearranged version. Q is the total charge. N is the number of electrons. QE is the charge of a single electron. Okay, so Q is the total charge. N is the number of electrons. QE is the charge of a single electron. Okay, and that's how we utilize this formula. So remember, I also mentioned one thing, that they need to match. I don't know how much I emphasized it. I don't think I spoke about it at all. So what I'm trying to say is, if the Q that you are using is the charge of, let's just say, a charge called B, then the number of electrons that you are going to get is electrons of B. Okay, let's just say you want to calculate the, in this case, charge, sorry, you want to calculate, like in this case again, the number of electrons transferred. What charge will you have to have? The charge transferred. The English like sort of has to match. Okay, what happens if, I don't know, you wanted the amount of electrons at A, whatever A is. You need the charge at A. They always need to match. I hope that makes sense. Sorry. Okay. So, yes, keep that in mind. So here, what do we want? We want the electrons transferred. So if we want the electrons transferred, it's this instance, by the way. Let's move it. If we want the amount of electrons transferred, we're going to need the charge transferred. So the charge transferred, oh wow, we actually got it from the previous question. Okay. Now remember the previous question, I said we could get a negative answer and a positive answer, just depending on which old we use. So both would work if you carry it over to the next one, because this formula requires us to actually use delta Q, change in charge. Delta Q is equal to N times QE, because this is the change in charge or the charge transferred, and it's going to give us the amount of electrons transferred because they always match. So when you if you're going to sub in the charge of Ibrahim, you're going to get the amount of electrons of Ibrahim, whatever example, right? So now in this case, I substitute delta Q. So I'll do both. Delta Q is negative and positive, right? So negative, what is it? Negative 14. Negative 14. Okay, then the other thing is you have to use, what is it? SI units. You have to use SI units for this formula. So the first two, you don't have to. The last one, you have to use SI units. So what is it? Negative 14. It's going to become negative 14 times 10 to the negative 6 is equal to N, number of electrons, times QE. So because this is negative, you're going to substitute a negative that. A negative QE. And you get N here as, let's just do the calculations. And here you get the number of electrons as 8,75 times 10 to the 13. There's no unit. It's just electrons. Okay. Let's do it if we did the positive value. 14 times 10 to the negative 6 is equal to N times. Now, because we substituted a positive, yeah, we're going to substitute a positive as well. And we're going to get the same answer. Exact same answer. Okay. So I hope that makes sense. How many electrons were transferred, right? You need the charge transferred and you substitute it into this formula. Okay, so let's move on to do this hard question. So we have charge A and charge B, okay? And the description of the question says charge A and charge A and B above were brought into contact and thereafter separated. They were brought into contact, they were made to touch basically, and thereafter separated. After contact, 2 times 10 to the 13 electrons are moved from A to B. 2 times 10 to the 13 electrons are moved from A to B. So according to that information, can someone tell me which is the more negative charge? If the electrons moved from A to B, which is the more negative charge? If the electrons move from A to B, which is the more negative charge? Yes, indeed, you are correct. It is A. Because remember, electrons okay, electrons always move from more negative to less negative. Electrons always move from more negative to less negative. Okay, so if the electrons are moving from A to B, A is more negative. Okay, did we discuss the difference between more and less negative? I think we did at the end of the last lesson, right? Tell me, people, what is more negative between 2 and 5? What is more negative between 2 and 5? Correct. 2 is more negative because it's closer to 0. What's more negative between 7 and negative 7? And then also one time, what's more negative between negative 5 and negative 4? Negative 7, correct? And then between negative 5 and negative 4? Negative 5, excellent. Okay, so we understand what more negative means. So A is more negative and B is less negative. Now, one other thing that I want you guys to take away from one being more negative and one being more positive is the following. The more negative one will always have a positive delta Q. Just remember that. The more negative one will always have a positive delta Q. The less negative one is always going to have a negative delta Q. The more negative one, positive delta Q. The less negative, negative delta Q. Okay, and again, we discussed it. Because the one that donates, okay, it loses electrons. So it becomes more positively charged. That's why its change in Q is a positive change. The one that receives is B, okay. It receives electrons, which means it becomes more negatively charged, which means its change in charge is a negative change. Okay, so that's really important for this question. Charge A and B above were brought into contact and thereafter separated. After contact, 2 times 10 to the 13 electrons are moved from A to B. Okay, so the only information we have is that this many electrons will move from A, sorry, not A and B, this is supposed to be A to B. And we know that it's A to B, so we know which one is more negative. The only formula we know with electrons Q is equal to N times QE, where I have information about the electrons. 2 times 10 to the 13 times QE is 1,6. You can put negative if you wish. 1,6 times 10 to the negative 19. Okay, when we do this calculation, we get 3,2 times 10 to the 3,2 times 10 to the negative 6 coulombs. So what information is this? Okay, well, we want to know what charge is this. The way to determine what charge is it is to ask yourself, what electrons did you substitute? We substituted the electrons that were transferred. Electrons transferred from A to B, that's what we substituted. The electrons transferred. Okay, so what charge is it going to give us? It's going to give us the charge transferred. Okay, and charge transferred is actually delta Q. Now that we have delta Q, we can use its formula. Delta Q is equal to Q new minus Q old. okay, where we know one of the Q olds, we know Q2s, Q old. Let's label them. I don't think they're labeled. Q1 and Q2. They A and B, but it's fine. Q2's old, that's we have, it's 4. Okay. Newly after contact, we don't have. However, we have delta Q. So we are working with Q2. Okay. Now, delta Q we can substitute as negative or positive, right? We substitute a negative. That's why we get negative. Delta Q we can substitute negative or positive, depending on whether we're working with the more negative or the less negative. So the Q old that we're working with has to be Q2. So someone tell me, is Q2 less negative or more negative? Is Q2 is the less negative, correct? So since Q2, I'm going to answer your question in a bit. So since Q2 is less negative, does it have a negative delta Q or positive delta Q? Since Q is the less negative one, it has a negative delta Q. So we will substitute negative 3,2 times 10 to the negative 6. If we were using Q1, we'd substitute positive 3,2. So is Q new minus Q old the same as final minus initial? Most definitely. I just prefer Q new minus Q old because they work better in all the equations, just the terminology. Q final minus Q initial is the same thing. So negative 3,2 times 10 to the negative 6 is equal to Q new minus Q old. Again, we know that I'm choosing 4. It's the only information I have for Q old. I don't have A's Q old. That's what they're asking me to calculate. And since it's the less negative one, it has a negative delta Q, and therefore it requires negative. Okay. And then Q old is 4 times 10 to the negative 10. Again, okay, you don't have to convert it, but I'm just converting it to be safe. So when you rearrange this, you get an answer for Q new. Okay, as Q new is equal to 0,8. 0,8 times 10 to the negative 6 coulombs. This is Q new. Okay, now that you have Q new, okay, what you can use it for is you found the value of Q new. You can substitute it into Q new's formula. What is Q new's formula? Q new is equal to Q1 plus Q2 divided by 2. We have the value of Q new. It's 0,8 times 10 to the negative 6, which is equal to Q1. Okay, Q1, we might be solving for Q1. Okay, because they want the initial charge of A, which is Q1. Q2 is 4 times 10 to the negative 6 divided by 2. 2 times 0,8 times 10 to the negative 6, 1,6 times 10 to the negative 6 is equal to Q1 plus 4,4 times 10 to the negative 6. Take that over as minus. For Q1, I'm getting an answer of, I think everything's right so far. If there's any calculation issues, please let me know. Negative 2,4 coulombs. Okay, so yes, that's us solving for Q1. So it's quite a process, okay? But if you know your formulas and you work backwards with your formulas, that's how you answer this question. So calculate the initial charge, okay, of A. Q is equal to N times Q. That's the formula we know with electrons. substituted the electrons, but because it was electrons transferred, we got charge transferred. Then we use the charge transferred formula to say delta Q is equal to Q new minus Q old. Okay, we found Q new that way because we knew Q old and we knew delta Q. Once we got Q new, we subbed it into the formula to say Q new is equal to Q1 plus Q2 over 2, and then we solved accordingly thereafter. Coulomb's law. Okay, so that was a revision of grade 10. Now we talk about Coulomb's law, which is new work. Okay, so Coulomb's law has the following formula: F is equal to K times Q1 times Q2 over the distance between them squared. So, what do we do first? Okay, so in Coulomb's law, right, what you do is you always work with once at a time, or maybe many, two charges. So you have one charge, you have another charge. Okay, just say one is positive and one is negative. Okay, they attract each other. One is positive, one is negative, they attract each other. However, when one is negative and the other is negative, they most definitely repel. Okay, and this could also be if they both positive. Okay, so that's what's important to understand from Coulomb's law. Always negative to more positive. Right. Okay. So in Coulomb's law, what they do basically is they'll give you two charges. Okay, now, when we discuss Coulomb's law, all right, we normally compare it with electric field because we have two of them, right? It is important to understand the difference because oftentimes, right, people confuse the two and they don't even realize that there's two kind of very similar formulas in the section, okay? One being that of Coulomb's law and the other being that of electric field. So Coulomb's law, firstly, okay, it is a force. It is a force in newtons. Okay, an electric field is literally just an electric field. It is what it says it is, right? It's an electric field, okay, and it has different units, okay, newtons per coulomb. However, Coulomb's law gives us, we work with a force. It is known as an electrostatic force. It's like in Newton, how we have forces in newtons. This is exactly what that is. It's an electrostatic force that two charges exert on one another, while electric field is just the imaginary lines that whatever the charge is, emits around it. The electric field that the charge emits around it. Right? So it is important to notice and to know the difference between the two. Okay? So Coulomb's law is a force, electrostatic force, and it's calculated with this formula. F is equal to K times Q1 over Q2. Sorry, K times Q1 times Q2 over D squared, also the distance between their centers, squared. Okay, so let's do an example, like a basic example, okay? So we have 5 microcoulombs and -4 microcoulombs. Now, they want us to calculate force that they exert on each other. Okay, the force that they exert on each other. So in this case, it doesn't matter whether it's attractive or repulsive forces, right? In order for me to use the phrase the force that they exert on each other, it doesn't have to be a repulsive force, like exerted on each other. It doesn't have to be like a pushing away repulsive force. It could be an attractive force that they exert on one another. All right. So in this case, it would be attraction because one is positive, one is negative. If they were both negative, repulsion. If they were both positive, repulsion. Right? So the force that they exert on each other, also according to Newton's third law, is equal in magnitude but opposite in direction. All right, so it's equal in magnitude. So if you can calculate the force, if you can calculate the force that one exerts on the other, then it's the same force that the other exerts on the first one. So that's where this formula comes in. F is equal to K times Q1 times Q2 over the distance between them squared. Let's give them a distance. I just say 2 meters. I think the SI unit is 2 meters. Let me confirm. Yeah. Okay. So this is where we substitute. K is a constant, 9 times 10 to the 9. Okay, it's given in the formula sheet. It is a constant indeed. Okay. And then Q1 is 5. You have to convert to SI units for this one, and you don't have to use negatives. Okay, and we divide all of this by the distance between them squared, which is 2 meters squared. The two things to note: we have to use SI units, and you don't use negatives. Okay, and then the second one is don't substitute the negative. Don't substitute the charge with the negative. Okay, so two things we need to note. Is Q in the formula, is Q the same as M? No. You're looking at the wrong formula. You're looking at the formula for gravitational. You're looking for the formula for Newton's third law. You need to look for the formula that under Coulomb's law for electrostatics. Okay, so in this formula, like I said, we don't use negatives. Okay, so that's why I don't substitute 4 as a negative. And I have to use SI units, so I have to convert to coulombs, basically. So I will do this multiplication, 9 times 10 to the 9, times 5 times 10 to the negative 6, times 4 times 10 to the negative 6, divided by 2 squared. Yeah, I get an answer of the force that these two exert on each other is equal to 0.045 newtons. So whether they ask the force that, let's call them, A exerts on B or B exerts on A, it doesn't really matter. Newton's third law, they're equal. And opposite, equal in magnitude, opposite in direction. Okay, so that's just a basic example of how to use that formula. Okay, now let's go to the actual questions of how they ask it. Okay, so here they want us to calculate F net, more specifically on Q2. Okay, so let's see where you can get challenging. All right. So the first thing to note on the left is just the conversions that I have for you guys. I don't know if this is gonna move. Okay. So the conversions are to get from millimeters to meters. you divide by 1,000. To get from centimeters to meters, you divide by 100. Obviously, vice versa, you multiply, but in this case, we always want meters because the SI unit is meters. Okay, so they want the net force on Q2. Okay, perfectly fine. Let's just discuss what that means. So you need to understand this is Q2. Both Q3 and Q1 exert a force on Q2. By the way, they all exert forces on each other. Q1 exerts on Q2 and Q3. Q2 exerts on Q1 and Q3, and Q3 exerts onto Q1 and Q2. They all exert forces on each other, but because they want the net force on Q2 or the net force at Q2, what we do is we focus on Q2. We focus on the forces that are exerted onto Q2 by the other two. So the force that Q1 exerts on Q2 and the force that Q3 exerts onto Q2. So tell me now, I'm asking, listen carefully, right? Between Q1 and Q2, is there an attractive force or a repulsive force between Q1 and Q2? Anyone else? Correct. Attractive is correct. I just wanted to see if anyone else was giving the answer. Okay, so you're 100% correct. It's an attractive force. Why is it an attractive force? Because opposites attract. Okay, it's a plus and it's a minus, and therefore they attract. Okay, opposites attract, and they will pull towards each other. Okay, cool. So it's an attractive force established. Now, listen carefully also. In which direction is the force that Q1 exerts onto Q2? In which direction is the force that Q1 exerts onto Q2? Anyone? Okay, very good. Attractive, very good. In which direction is the force that Q1 exerts onto Q2? To the right, question mark, right. To the right. Okay, everyone is so beautifully incorrect. Okay, so let's consider, I am focused on Q2. I don't care about the other forces. I don't. I want to know what effect is this having on Q2. Let me rephrase my question and see if you answer this time correctly. In which direction is Q2 going to move because of the presence of Q1? Ignore Q3. Ignore this for now. In which direction is Q2 going to move because of the presence of Q1? Ah, yes. In the left direction. Now we say left because attractive means that it pulls it towards it. So that's why to the right is incorrect. Because Q1 exerts an attractive force onto Q2, so the direction of that force that's exerted onto Q2 by Q1 is in the left direction. Does that make sense? This is, we call it F by 1 onto 2. Okay, let's just repeat. Okay, so Q1 attracts Q2. It's a pulling force. So yes, it always seems like it's to the right, because why? For some reason, our brains want to consider this. We want to consider that Q1 is moving towards Q2. So no, we don't care about Q1. Okay, we don't care about Q1. We care about Q2. How is Q2 being affected? So if you want to know the direction that a force exerts, a charge exerts on another, ask yourself, is it pushing it away or is it pulling it towards? The fact that Q1 is pulling to Q2 towards it means it's an attractive force towards it, which is in the left direction. Now I ask you again. Now we work with Q3. Okay. The force between Q2 and Q3, is it attractive or repulsive? The force between Q2 and Q3, is it attractive or repulsive? Okay, repulsive. Very good. The force between Q2 and Q3 are repulsive because they're opposite. I mean, because they like, and like charges repel. Always remember, opposites attract, like repel. Opposites attract, like repel. Okay, so if they were to positive and a positive, they would repel as well. Now, okay, in which direction, okay, is the force that Q3, I know the way I phrase it, it sounds weird and it makes you want to say the wrong answer, but there's nothing wrong with my English. Like, it makes perfect sense, right? In which direction is the force that Q3 exerts onto Q2? In which direction is the force that Q3 exerts onto Q2? See, the word exerts always just sounds like you're pushing it away. That's why also. Okay, we have a couple of lefts. YouTube. Anybody on YouTube? Repulsive. Correct. Okay. So to the left is indeed the correct answer. Why? Because we can ask ourselves the question, in which direction is Q2 going to move because of the presence of Q3? If we just ignore that for now, right? In which direction is Q2 going to move because of the presence of Q3? Q3 pushes Q2 away. So the direction that it's going to move, okay, is to the left as well because of Q3. We call this F by 3 on 2. The force that 3 exerts on 2. No, it wasn't right. It was left. I hope you understand why it's left now. Because it's a repulsive force. So again, we don't care about Q3 and how Q3 is affected. We care about how is Q2 affected. Q2 is affected by a left force because it's being repelled away from the right. It's being attracted towards the left, towards Q1, and it's being pushed to the left again by Q3. Nope, you can't retract your message. I saw it already. Okay. I think YouTube is a bit delayed. Okay. So, yes, now we can continue. Okay. So direction is extremely important in the section. Direction is extremely important in the section. One thing to note, please, negative in the section does not indicate direction. This is not vertical projectile motion. This is not, I don't know, work power energy. Negative does not indicate direction. Negative just represents a negative charge, meaning excess electrons. Okay. Direction we'll sort out with these vectors. That's why we draw these vectors so we can sort the direction out. Okay. So now, before we do anything further with the vectors and the direction, let us actually calculate the magnitudes of those forces. Which forces? So firstly, I'm going to write my main formula. My main formula is F is equal to K times Q1 times Q2 over R squared or D squared. So I want to calculate F by 1 on 2. Okay. F by 1 on 2, the force that 1 exerts on 2. Remember, the force that 1 exerts on 2 is the same force that 2 exerts on 1. Okay. So all I do is I substitute the value. So 9 times 10 to the non. Q1 is 6 microcoulombs. I have to convert in this formula, and I do not substitute a negative. So 6 times 10 to the negative 6, and 18 microcoulombs, 18 times 10 to the negative 6. Divided by the distance between them squared. There's multiple ways of doing this. 3 centimeters, okay, you have to divide it by 100 to get it to meters. So you can put 3 over 100 and then square it. You can put 3 times 10 to the negative 2, because that's like multiplying by 100. I'm just going to say times 10 to the negative 2. Or times 10 to the negative 3. Okay. Oh, shucks, man, my camera switched off again. Okay. So, yes, so you can do that. Okay, and don't forget to square it. Alternatively, you could even just divide it by 100 and then substitute 0.03, I think it would be. Okay, I prefer scientific notation, so I'm going to be following that way. Okay, but you do whatever you need to do to convert it to meters. Meter, okay. So then when we do this calculation, we get the force that one exerts on two as 1080, correct. Okay, so for now, we're just calculating magnitude. So yes, sure, you could say left, right? But also remember, our vectors have done our direction for us already. We know which direction it's in. Okay, but you're correct, 1080 to the left. Now, what else do I want to calculate? I want to calculate, let's get rid of this. F by 3 on 2. F by 3 on 2 is going to be K, so 9 times 10 to the 9 times Q1. So it's 3 on 2, so we're working with 2 again, between 3 and 2. 18 times 10 to the negative 6, and 12 times 10 to the negative 6. Okay. Then we divide by the distance between them. So I'm just going to say 2 times 10 to the negative 2 squared. Please don't forget to square. Then the force that 3 exerts on 2 is equal to, yeah, correct, 4860 newtons. Again, we can say left if we'd like. Okay, let's convert this. Okay, so now we have the force that one exerts on 2. We have the force that 3 exerts on 2. We have the direction of those forces. How do we calculate F net in this case? So, okay, of course, F net is going to be some sort of combination of the two vectors that we have here, right? Taking these two vectors. What would we need to do in order to get F net with our two different forces that we calculated? Okay, 100%. When they are in the same direction, both are left or both are right or whatever. When they are in the same direction, you will add them. So F net in my case is going to be what am I doing, man? It's not Python yet, sorry. You just add them, that's it. You add them together to get F net. Okay, let's do this. How do you get F net? You add them. Why are you adding them? Because they're in the same direction. So it's like vectors, right? When two vectors are in the same direction, you add them. When two vectors are in the opposite direction, you subtract them, right? So here we add them, okay? So F net is equal to 1080 plus 4860. And we get our final answer that F net is equal to, I trust your calculations, 5940 newtons to the left. That we will put direction for. Okay. Okay, so let's call it there. And then next week we will continue with the next example. Okay, the next few examples, hopefully. But yeah, nevertheless, so that's how we do a basic F net question with 3 charges using Coulomb's law Okay, and in this case, the forces were in the exact same direction, so we added them to get F net. So yeah, if you guys have any questions, you can let me know. Any advice for an exam on Wednesday? Okay, so the same advice I gave someone earlier who asked. Look, if you're writing, what I would recommend you do is, you need to study, number one, of course. Number two, good luck. Number three, so depending on how much you know, like if you know your basics and your theory, I would suggest going through past papers, right? Go through your past paper questions, right? That's the best way to know what you don't know. And it will be the easiest thing for you to be able to tell yourself, like what you know and what you don't know, because you'll be doing the work and then you'll see, okay, I don't know this, I don't know this. Whatever you don't know, you can go back to the videos, try and rewatch the videos, see if you can get a better understanding from there, then try your questions again and take it from there. If you're really stuck with a question or concept afterwards, you can message me and I can try my best to help you. But yeah, my advice is just to practice past papers, and that's going to give you confidence to say, okay, I'm ready for the test, because you've done questions and you know what the questions are like. And if you're getting the questions correct, then you will be fine. But yeah, I don't know. Are they done? Are you guys done with exams? I think some people are, some people aren't. Some people are done and some people are like writing in this week or something. Okay, cool. But yeah, let's end it there. And all the best, guys. I wish you guys a good week at school and study hard for those who are writing. We'll meet again next week, okay, where we will continue with this. What are we doing? Electrostatics. And yeah, for those of you who are on holiday, and for those of you who are going to be on holiday, please do note that we will be continuing classes during the holidays. Okay, it's once a week for 1 hour, so we're not going to stop it. Whether we finish syllabus for the term, maybe we will do revision. Okay, so that could benefit you. We're probably not going to start like next term's work, just because some people won't join. Okay, however, we will be doing revision. So I would advise that you do join the lessons, okay, so that you can benefit from whatever it is we do, whether it's revision. And I will maybe like take a poll to say what questions you guys want to do, like what topics do you guys want to do, and then the most urgent one, we will do those first. You already got your marks back, or how did you guys do? Physics paper was horrible. If you do have it, you can send it to me and I can go through it. If you do have your paper, you can send me pictures of it and I can go through it and see. How did you guys do if you already got your mark back? Okay, but yeah, on the holiday thing, yeah, please make sure you guys attend, and yeah, hopefully it will go well. Okay, well done. That's excellent. That's a very good mark. Keep it up. Okay, so sometimes that does happen. Okay, sometimes it's just exam stress, or other times it's you have to practice, right? So we can't sit in tuition and practice like 500 examples, or okay, let's just be like, we can't practice like 10 examples even, right? We can do 1, 2 at most. So you have to practice extra, because there are slightly different pools of questions. Like we might not be able to cover a certain style of question, even though the content is the same, the syllabus, same part of the same topic, and it's the same basics that you need to know, but it's just the style of the question that when you do it, you might get it wrong. When you're doing a past paper, then you check the memo and then you know how to do it, and it will be better from there. But yeah, if you do have that paper, send it to me, then I can go through it. But yeah, okay, cool. So let's end it there. I'll see you guys next week. Good luck again with school, and good luck for those of you who are writing. And yeah, if you need any help, message me. I still have a few messages to respond to, which I'll try and get to today. But yeah, all the best again. Jazakallah khair. Thank you guys so much. Assalamu alaikum and goodbye.